Alrighty, today we are talking about learning target 3.3. I can use the periodic table to write and interpret electron configuration. So today we're going to be talking about electron configuration. Alright, so what electron configuration is? It shows how electrons are arranged around the nucleus. So the key here is that electrons are located on orbitals. Not orbits, but orbitals. So orbitals, just think of it as like an electron cloud, places where the electron can be seen. Orbitals are distinguished by a number and also a letter. Superscripts, that means up, above, super, represent the number of electrons in a block. So some rules when you're thinking about this. The lowest energy gets filled with electrons first. So just like the Bohr model, the closest to the nucleus, that's the lowest energy. That's where the electrons want to be. When they're up in outer energy levels, they have more energy. So lowest energy gets filled first. Low number represents a low energy. Orbitals have letters that represent a block. So block is kind of how the periodic table is broken up into when we're talking about orbitals. S orbitals, that's the lowest. Those are the alkali and the alkaline earth metals. Then we have the p blocks. They're the representative elements, the boron, carbon, the halogens, oxygen family. The d block is the transition metals, and then the f block is the lanthanides and actinide. So here's kind of what it looks like. Here we have our s's. Notice that helium is still part of the first s. Here are our p's, our d's, and the f's at the very, very bottom. Now, remember that our f's actually go in right here. So they're actually inserted right there. Remember that. Make sure you remember that. So, some things that you need to know. The s orbitals. There's one orbital, and it holds 2 electrons. So each orbital can only hold 2 electrons. Now when we're talking about orbitals, we actually have to do orbital diagrams, which that is the next video. The p block has 3 orbitals, 6 electrons. The d block has 5 orbitals, so 10 electrons. And the f block has 7 orbitals, or 14 electrons. All right. So here's an order of what the levels are filled. This is something that you guys need to know. First, it's filled as the 1s. So we go 1s, 2s, 2p, 3s, 3p. Then we go 4s, 3d, 4p, 5s, etc. You guys can read that. Little cheat when you guys are looking at this. It fills in just like it is on the periodic table. So 1s, 1s, then 2s, 2p, that's not supposed to happen, 3s, 3p, then we have 4s, then we go through 3d, then 4p, etc. So that's where those order comes in. So let's do an example real quick. Fluorine. For all of these, we're going to assume that it's a neutral atom. So we can assume that the number of protons equals number of electrons. So that's a big assumption. When we do charges, we have to either add electrons or take away electrons away. So with fluorine, we know that Z equals 9 because the atomic number equals 9. So we know that there are 9 electrons in the fluorine electron configuration. So the first thing we have to do, we have to fill in the S first. So just like here, we go 1s1 because the superscripts, they represent the number of electrons. So we go 1s2, 2s2, 2p5. All right, now that makes no sense. So let's talk about it when we're looking at the periodic table. Here we have 1s1. Over here, we're going to have 1s2. that's going to be our hydrogen, our helium. Here we have 2s, 1, 2s, 2. Then we get to the p blocks. 2p1, 2p2, 2p3, 2p4, 2p5. And that is fluorine. 2p5. So a way we can double check. We can look at the superscripts and add those up to make sure that the superscripts equals our total number of electrons. So we do 2 plus 2 plus 5, and that equals 9. So we're good to go. So let's do another one. Calcium. The first thing that you have to do, you got to figure out how many electrons it has. So we know we can look at our periodic table, look in your book, look in your folder. We know that there are a total of 20 electrons in calcium. Now we have to fill it in order, just like we did for fluorine. So first thing that comes first are our 1s's. So we have a total of 2 electrons can fit in the 1s. So we're going to write that. So we have 1s2. And we're going to come back. So we have 1s2. Now we're to lithium. So now we got to do our 2s's. So lithium, so we have 2 right here. So it'll be 2s2. So 1s2, 2s2. Now let's keep moving. Sorry, I do that backwards. Then we have our p's. We have 2p1, 2p2, 2p3, 2p4, 2p5, and 2p6. So we're still not to calcium yet. So we have 2p6. Now we get to our 3 s's. We have 3s1, 3s2. We're in magnesium. We're still not there yet. So we write our 3s2 down. Now we got to go to our 3p. So we just did 3s2. Then we go 1, 2, 3, 4, 5, 6, 3p6. So we write 3p6. And we're still not to calcium yet. Now we're going to go 4s1, 4s2. And we're at, with 4s2, we're done. We're to calcium. 4s2. So that is the electron configuration for calcium. If you guys would, go ahead and do the electron configuration for cobalt, lead, and sulfur. Now be careful with lead. When you're looking at lead, make sure that you include the lanthanides and the actinides. You need to include your F blocks. Remember our F blocks. This is going to go right here, and this goes right there. So eventually you're going to have to go the other way as well. So if I give you 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. We know that we have 1 electron in the 4s block. So we need to find the 4s block. Here's the 4s block, and we only have 1. Calcium had 2, but we know it only has 1. It has to be potassium. Another way we can check, we can add up the electrons. 2 plus 2 plus 6 plus 2 plus 6 plus 1 equals 4, 10, 19. Right? I'm missing one. 10, 12, 18, 19. No, I'm not. Equals 19. Another way, quicker way to do that is like I did before, skip to the last section and see where it matches with the periodic table. And that is it for electron configuration. So right now, you just have these 3 to do on your own. You should be good to go. Have a good day.